This is the Amp Hour Podcast. Released June 24th, 2018. Episode 397.7. Impedance matching with Jeff Keyzer and Michael Ossmann. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And this is Jeff Keyzer of MightyOhm.com.
And I'm Michael Ossmann of Great Scott Gadgets.
And we are sitting in on the shore of Doe Bay, Otter Cove, where there maybe I think that's actually a stick now. I thought that was an otter.
Oh, I totally thought it was an otter.
Yeah, it's that's disappointing. It's an otter.
An otter of disappointment.
That's right. But here we are at Tour Camp, another recording here, and this is official. I'm going to call this an official impedance matching episode.
Excellent.
We've done one before.
Yeah.
Have you been on an impedance matching episode before?
I don't know what that is.
Is this
I think you have, but it might have been before it was called impedance.
I think that's probably true. Right? Jeff's the OG.
Yeah.
It's so basically impedance matching is when we bring past guests on. It's me and two other past guests. So, and I guess you and I have co-hosted so much anyway. So yeah. So we're down here by the water. We're surrounded by people. We're getting the reverse engineering podcast is invading here. They've got a big inflatable thing. This is insanity. This is absolute insanity. What do you guys? Are you guys gonna swim in that thing?
Yeah.
Okay. We were thinking about recording the dinghy, and then we were reminded that you were going to be taking it out there. So.
And your stuff would get wet.
Well, it's just record. It's just electronics. That's cool. We're cool.
Later.
Yeah.
After we record.
Yeah. So we've been.
You tell us how the water is. We'll come in later.
Yeah. It's been a good tour camp so far. We're on the last day. Jeff's leaving tonight.
Yep.
So I figured I got to get this in here. So what are you thinking so far? How about how it's going?
I think it is awesome because not only are we in an amazing location, but I'm surrounded by people that are also equally awesome.
Mike, what do you think?
Yeah, I'm having a fantastic time. This has been a great tour camp, as always.
Yeah, so you guys have both been before, so.
Oh, yeah.
So, Mike, you and Great Scott Gadgets have been doing creme brulee throughout the weekend because, what's the story?
That's right. Oh, what's the story? Where to begin? Well, at TourCon, actually, in San Diego, almost a decade ago, there was an outing for what was supposedly the best creme brulee on earth. And we went out to this restaurant, and of course we all, when it came time to dessert, we all ordered creme brulee because it was supposedly the best creme brulee on earth. And,
right.
And somebody asked me how it was, and I was like, it's good, but it's not the best creme brulee on earth.
Yeah.
And they're like, well, where have you had better creme brulee? And I was like, well, I've made better creme brulee. and it's been attributed to me that I've claimed to make the best creme brulee on earth, and I want to tell you right now, I do not make that claim.
Okay, good.
But I do claim to make better creme brulee than this one restaurant.
Got it.
And so anyway, people in the TourCon community started asking me to make creme brulee for them from time to time, and so this is actually the third tour camp at which I've made creme brulee. The first one I made half a dozen, and the second one I think me and some friends made about 2 dozen. And so this year we decided to ramp up and feed creme brulee to everyone at camp.
Yes.
And it's been quite the project.
Yeah, I saw you have a sous vide up there, and that thing is it's a cooler, right, with a heater controller in there?
Yeah, it's a cooler that is just within the checked baggage size limitation.
Oh, really? Wow.
Yeah. And so it's the biggest one we can get within a regular checked bag allowance, and we can fit in it 120 4-ounce canning jars.
Wow.
And so
that's the squat jar, right?
Yeah, the little ones.
Yeah.
And the jelly jars, they're called.
Yeah.
So we have 120 servings, 4-ounce servings of creme brulee that we cook at once, and right now we are preparing our 6th batch of 120 to serve to campers here at Tour Camp.
Nice. And me and Jeff actually just had it delivered by Taco Copter.
That's right.
So we just used.
That is awesome.
It is that. Well, it was based on your tweet. Joe Fitz, past guest of the show, is doing a Taco Copter service. We used the Shady Tell, who we talked to Shady Tell on the show earlier this week.
Nice.
And we called up for a creme brulee. So I think that's like the pinnacle.
Yeah.
Of
Creme brulee, aerial delivery of creme brulee, thanks to Taco Copter, thanks to Joe
This
Fitz.
is peak tour camp.
I think
and it's probably the one situation when a glass container hurtling from the sky is like a good occasion.
Also of like an egg-based product being served on a warm, like on a 75-degree day. It's like,
right.
I mean, it's delicious. Don't get me wrong, but it's
delivered by quadcopter and ordered via camp phone network that was set up on the spot by Shady Tell.
Yeah,
amazing.
We did it.
Yes.
Well, that's good. So what else has been going on? Well, Jeff, let's start with you because you haven't been on. I mean, we obviously will have you back on at Christmas time,
right?
But
as is expected,
as is the tradition.
Yeah, as is the tradition.
What's been going on in your life?
Oh gosh, so I've been keeping really busy. I'm still doing kits, still doing the Geiger kits. I just recently started working with Elector, and they are in the Netherlands. Popular electronics magazine. They have a web store, and they are now selling Geiger counter kits on their store. So I've been working with those guys, and that's been going really well. Keeping busy, working on projects, working on non-electronics projects, which I don't know if that's okay.
What?
No, that's okay. I mean, we won't talk about it extensively here, but I think it's.
No,
I mean, you're okay. You have surely, Mike. You have some. You were cooked 600 egg things.
I'm
so.
totally joking. We were just talking about creme brulee.
Yeah, right.
No, I've been continuing.
This is Jeff's creme brulee, except it's
my creme brulee. Yeah, my creme brulee is a 1962 Sunbeam Alpine with an engine that refuses to stay together.
Talk about an egg. Talk about an egg.
Yeah. How about them apples?
Yeah, right.
Yeah. So it's a project that I've been working on for a while, and I am preparing to install the engine in the car. Maybe tomorrow,
nice.
And get
for
it back
the third
on the road.
time, according to your wife. Yeah.
Like the third time.
Yeah.
So
I think a lot of people who listen to the show might be Car Talk listeners too. Is electronics troubleshooting similar to car troubleshooting, or how different is it?
Oh, gosh, I think you have a lot of the same problems in cars as you do with electronics. Like you get bad parts
when
from suppliers.
You have
no idea what you're doing, and you have to figure it out. And
you're hitting things with hammers.
I mean, I think the thing is like the stakes are a little higher because when things don't work, like they really don't work, and it can be a major project to even get to the thing that's not working. And I think that's the part that's not as fun. But I think that. For me, I've always thought it was really important that I do electronics for my day job, and sometimes I just want to do something completely orthogonal and different at night. And so cars are that thing for me, and working on like complex mechanical systems and the tools and everything that are associated with that. Like just like how we have really fancy soldering irons you can get for electronics, like there are micrometers and tools for doing mechanical work also. And it's been cool to kind of geek out on something that's like totally different and understand like not just why it's like figure out the part that's broken, but like how is it supposed to work and how are they designed, because this car is really old and things were different back then, and trying to figure out like how things are supposed to work that long ago is hard. So it's interesting.
That's great, man. I'd say my creme brulee is piano, but I don't think that really doesn't cross over to electronics as much. You're a musician, right, Mike?
Yeah, I am.
Yeah, guitars these days?
I've got my little toy guitar in the cabin.
Oh, you do?
Right
Nice.
Now.
Yeah.
You should try it.
That's great.
It's good for traveling.
Yeah, that's tough with. I saw one that actually the neck completely folds down.
Oh, really?
And you screw it in. Yeah, this guy Josh Turner is a.
So I'm not in the camp of people who like actually spend money on travel instruments.
I see, yeah.
I buy the toy from the actual toy store, and you can spend $40 or $50 on a toy guitar that actually is a pretty decent instrument.
Interesting.
And the one that I have now, I've had for I think almost a decade, and I travel with it all the time, and I throw it into overhead bins. I've never had a case for it, and it actually has held up. And it's great.
Probably fits the application too of like I came here and I was like, oh, I'm gonna get this done and that done, and obviously I've been talking to great people, and talking about just experiencing the culture here. But I was like, I was gonna get stuff done, but it sounds like taking a travel guitar is probably pretty similar. It's like you take it with you, but you pull it out like 2 or 3 times maybe.
Yeah, like sometimes I just don't play it at all, but other times it's super nice to have and like really calming and nice to have like a little chance to practice and just to play and like relax.
Yeah,
it's really great.
Yeah. Well, speaking of relaxing, we were all, I think you've had everyone at the camp now pretty much putting together these badges too that are kind of integral with the creme brulee. So tell us about those.
Yeah, so this is part of the, it's associated with the creme brulee camp project. And this is all thanks to the whole Gray Scott Gadgets crew that we have here and back in Colorado. But most of us were able to make the trip here. So Taylor and Jacob, who gave a talk yesterday or on Thursday at camp about the project, and Dominic and Matt are here. So we've got a whole group of people who are doing this whole sous vide creme brulee project and serving creme brulee to everybody at camp. But part of the project, or part of the way that we are able to make so many servings of creme brulee is by doing these large batches of sous vide, where we are cooking the custard in these jars, and we're gonna have hundreds of jars that we're gonna hand out to people. What are they going to do with the jars? Are they going to just throw them out? And
you can't use plastic jars.
Right. We need like canning jars.
Yeah.
And so we're like, what can we do to avoid having all this waste? And we're like, well, we could always have people make a jar of fireflies, which is a time-honored microcontroller project. I think everybody.
I was going to say even just a camping thing of catching.
Oh sure, right? Yeah, it is. It's like an outdoorsy kind of thing.
So you're a kid, you catch fireflies.
Yeah. And for people who get into microcontroller projects, I think everybody at some point has done a jar of fireflies project, whether they've
it's effectively
copied
a blinky at random intervals, right?
Yeah, you put some LEDs in a jar and you blink them in some pattern, and so many people have done this kind of thing. It's a great project for people who are new to microcontrollers or new to soldering, and so I just contacted the tour camp staff, the crew, a couple of months ago, and I was like, hey, we're going to be handing out hundreds of jars, and we had this idea to maybe give people a jar of fireflies project. Do you have a plan for a badge for tour camp? And they were like, oh, we've been thinking about an electronic badge for tour camp, but nobody's actually picked up the ball and ran with it, and we don't have a plan right now. And I was like, well, here's my proposal. I'm going to design you a badge. It's going to be round, the circular badge that replaces the lid of a canning jar, and is just held on by the band that holds on the regular lid, and people can solder up a little jar of fireflies kit. And we're going to be giving everybody jars with creme brulee in it.
Yep.
And so we're going to have a badge for tour camp that is this electronics kit that's fun for people and gives them a reason to take home their jar from creme brulee.
Yep.
And they said, that sounds awesome, do it. So I started designing it, and I got Osh Park on board. So Osh Park donated all the PCBs, and I designed the board, and I bought the components and brought them here to camp, and people are soldering them up and enjoying delicious creme brulee and making little jars of fireflies to hang around their neck or keep around their campsite or take home and have fun with.
Yeah, that's fantastic. I really like the look of it. And I think it's funny. It's funny watching people do the. You could tell who's been doing electronics in the past and cut their leads all short, and then they didn't read the directions of oh no, they're supposed to be dangling there,
It doesn't matter. You can solder it up however you want.
Yeah, I know.
Like some people have made their LEDs long so that they can dangle in the jar. Some people have kept them short so they can wear their badge without having to have a jar around their neck.
Right.
Some people are going to get two badges and have one for wearing and one for their jar.
Yep.
And there are multiple ways to attach the LEDs because it's a Charlieplex thing, so you can make your own Charlieplex matrix. And the board officially supports 6 LEDs, but actually the design supports 12, so you can make a whole matrix of 12 LEDs and put it in a bigger jar if you want. Or you can maybe use the short leads and have a wearable design while you're here, but then when you get home and you have a bigger jar, you can do something more ambitious with the LEDs. It's all up to people to assemble it however they want.
That's great.
I really like the programming interface with the pads around the circumference of the jar of the PCB, and then pushing it into a programmer, which is awesome and gets around just the challenges of having little headers and things like that. It's just really simple and it works really well.
Yeah, that was kind of partly laziness on my part, that I didn't want to have pre-programmed microcontrollers for people, and I was like, how are people going to program their badges after they assemble them if we don't pre-program the microcontrollers? And so we came up with this test jig that had to accommodate whatever LED structure people had attached.
Right, exactly.
Right, so we needed like this big hole in the middle and this ring of pads around the outside edge that attached to the spring pins on the jig. And it worked out pretty well. And one of the reasons, actually, the original reason that I made this ring of pads around the back edge of the PCB, I wasn't actually thinking of the test jig originally.
Oh, yeah?
I was thinking about the fact that Bunny was going to be here, and Bunny was donating kits from Chibitronics kits.
Oh, yeah.
That have that are all like cool paper electronics projects with copper tape, and there's like adhesive, conductive copper tape. And I was like, I want the badge to integrate with the Chibitronics.
Right. So this could be the controller.
Right. So you can use your badge as a controller for your Chibitronics toys. And so that's why I put this row of big pads around the outside of the underside of the board.
Yeah.
And it's a one-to-one mapping of the pins of the microcontroller around the outside of the board. And that way you can just use your badge as a controller for the Chibitronics.
Right. Kind of reminds me of like the lily pad. They kind of like the size and scope of it kind of looks like.
Yeah, very much.
Yeah, lily pad. You used to do that or no?
No, but I'm familiar with them.
Okay.
Yeah.
That's great, man. So what's new? What's new in the Great Scott Gadgets world these days? I suppose it sounds like you guys are growing in leaps and bounds.
Yeah, we're growing. We have
still up in the hills of Colorado.
A lot more people these days, and we are gearing up for a big release of Great FET, which is something I've been talking about for a few years now, which is a big project of ours to make a kind of a general purpose microcontroller project with high-speed USB performance, and it's like a development board / hardware hacking tool / custom USB peripheral, and it gives you kind of a Python, like an easy to use Python interface. So you plug, it's kind of a peripheral model. So think of it sort of like an Arduino, except like a much higher end microcontroller and high speed USB, and more of a peripheral development model instead of an embedded development model. So you plug the thing into your USB on your laptop, and then you interface with the outside world via like an easy-to-use Python shell on your laptop. That's kind of the idea of Great FET, and it's something that we've been working on for a good long while now, and we should actually be shipping later this summer.
That's great, and that's going to have like things that you can plug in. It's like a pluggable thing, right? So you can add on a
It's a huge expansion interface.
Yeah, right.
It has a 100-pin expansion interface.
Got it.
And add-on boards we call neighbors, in honor of Travis Goodspeed.
Yep.
And who created the Good FET, and the Great FET is the kind of next generation Good FET. So we actually implemented MSP 430 JTAG, which was the original purpose of the Good FET.
Oh, I didn't know that
From the very origin of Good FET, Travis created it as his own MSP 430 JTAG programmer and debugger. And so we've just recently ported a bunch of Travis's code to the Great FET so that we can do tour camp badge development and programming.
So that's actually what it's programming. That's the MSP 430's on board, right?
Right.
Yeah. You know, I'm not seeing as many projects with that. I mean, I know it's all out there, but it's like I'm not seeing as much out in the world for MSP 430 these days.
These days, ARM is probably a more compelling microcontroller architecture for most projects.
Right. 32-bit versus 16.
But I had a pretty good reason to use MSP 430 on the Tour Camp badge, and it was that I was just copying an older project of mine I did quite a few years ago, and used an MSP 430, and I was like, this was a kind of final hour sort of badge at the last minute thing, and I was like, well, we could just take this old project and just modify it a little bit. So that's why I ended up with the MSP 430.
That's the way to do it.
Yeah, because it was originally like a super low power energy harvesting kind of thing, and I ditched the energy harvesting part of the project for the purposes of the Tour Camp badge and just put a little coin cell in it. But it's still a really low power design, and people should be able to run their jar of Fireflies from Tour Camp for like months or maybe years off this coin cell. In theory, I haven't really tested it.
We'll see who's around in a while, like that one light bulb that keeps staying lit all those years. Yeah. So Jeff and I were talking a little bit earlier, and I thought it'd be an interesting conversation for the three of us around kind of learning, because there is so much learning happening at Tour Camp and other hacker-style conferences around. So I did a KiCad tutorial yesterday. I was a little frustrated with kind of getting through stuff. Obviously, you've done a lot of stuff with SDR education, and I was kind of wondering, like, both of your philosophies around teaching and learning electronics, because obviously both of you are very far along in your journeys, right? You're kind of near the top, I'd say. You know, like, not that there's not more way to go, but like there's always more to learn, right? But it's just like it's tough to empathize with people that are listening, that are brand new, right? It's not tough to empathize. It's tough to actually have those exact same feelings.
Yeah, and it's tough to remember what you didn't know.
Exactly.
Sometimes.
Exactly. Right. So me and Jeff were talking about, like, so the thing I always explain is, like, so say you are looking at a schematic and you don't know what a diode is.
Right.
What do you Google for, right?
Oh yeah.
Right. It's like triangle line, triangle line,
triangle with line.
Google. What is this?
Yeah.
And you can't like draw a shape, you know, and if you don't know anyone, that sucks, you know. And so like, Jeff, like, what do you do when you're stuck, or like, or how do you start teaching someone like that?
I think it's hard. I always kind of go back to my first experiences in electronics, and Forrest Mims was kind of a big figure in my early electronics like learning, because he had the Getting Started in Electronics book, which Radio Shack, like every Radio Shack in the country sold, and he had the engineer's notebooks, and that was my first exposure, like my absolute like early like step one into electronics was that for like a birthday one year I got an Archer soldering iron kit with like the little clippy thing with the spring to do the heat sinking on the transistors, and I got a Getting Started in Electronics with Forrest Mims, and then I got a like one of those 60-in-1 or 100-in-1. Mine was a 100-in-1 electronics kit with the springs, and I really liked Forrest Mims' approach to teaching electronics, because he focused on like taking each component and breaking it down to what is kind of the minimum amount of functionality that you can distill, say like a transistor. So like if you're just getting started, I think like the paradigm of like transistor is switch. Right. Like
ignore
that's kind of all you need to know. You got this terminal that turns it on and off, and you got this terminal, that's the thing that gets turned on and off and opens and closes the circuit. And I think that when you're just getting started out, having like that level of knowledge is a really good way of not getting totally lost when you look at a schematic. And like his books had lots of examples and lots of reference circuits that like I never understood exactly how they worked, and like all the timings and voltages and stuff, but you're like, oh, okay, I've got capacitors, I've got resistors, I've got transistors.
It's enough to gloss over certain things, but get some feeling around like, what is what.
This is the thing that's switching the light on and off, and like you kind of get it. And I think that having that conceptual view is important when you're just getting started, because you need to have some way of breaking down this really complex thing into pieces that you can understand.
Right, so that's like coming at it from the pure hardware standpoint. Mike, you get a lot of people that you're bringing in from the software world, and I was talking yesterday with Nick, who was at the class, and he was also talking about Dimitri's training, and you trained with Dimitri as well, and it seems like the security community is actually really good at going from zero to full speed in a short amount of time, and specifically for the software people. So I was wondering, like, how you see that in the SDR space too.
Yeah, like so I teach SDR all the time. I don't teach a lot of hardware. I've done a little bit of hardware teaching or talks on like learning hardware, but like mostly the reason I know hardware is to support my tool building habit for wireless security research and development. And so like I'm more of a people say I'm a hardware hacker, but really I'm more of a wireless hacker who makes hardware. And so I'm constantly teaching people wireless hacking. I'm teaching them SDR, and occasionally teaching them a little hardware. And like that, I'm usually teaching things to people who have some kind of software background. And like the thing I always tell them is, oftentimes people have like trepidation. They're like incredible software people, just like super smart,
20-year security software people, right?
Oh yeah, who like can just look at some code and they just look at it and bugs fall out. Like, and they're like, oh, I see that bug. Oh, that's exploitable. Right. And like, they're amazing. They're so much better at software than I ever was. But they're scared of hardware, or they're scared of wireless communication, or they're scared of digital signal processing, or whatever seems new and foreign to them. They're scared of. And I'm like, you know what? How many computer languages do you know? And they're like, they run out of fingers on their hands. And I'm like, learning hardware is just one more computer language.
Interesting.
It's one more language.
Yeah.
You sit down and learn a new language for a project because it seems like the right thing to do for that project. Like okay, you can learn hardware for a project too. Like you can start small. You can learn the basics, like Jeff is talking about, like getting started with electronics and learning that a transistor is a switch. You can get a long way into electronics just without even going beyond a transistor as a switch.
Right.
There's so much that you can do with such a really a small amount of knowledge, and it's just a matter of like realizing that is a leap you can make, and that taking baby steps helps.
Yeah.
Like finding a project, a small project, and going with it.
Yeah.
Like I always encourage people to do that, because that's exactly how they learn a new programming language.
Sure.
I'm like, what do you do when you learn a new programming language?
Hello world.
And they say, oh, well, hello world.
Yeah.
And then I want to do this one project, and it's not too big, not too small, like enough to learn the language. I'm like, that's exactly what you need to do to learn electronics. Start with hello world, and then do a small project, and then you will be like leaps and bounds beyond where you ever thought you could be.
I think like one of the things that's interesting in electronics is that like starting with something that works is also a really good way of learning, because like you don't necessarily want to spend all your time learning the syntax of a new programming language. So maybe you take somebody else's code and then you modify it to do what you want to do. And that way you don't really need to understand at once all the finer points of like how to interact with all the components, but you can isolate it down to, okay, here's the thing that I want to do that's different than what this does, and like focus on just that change, and not have to learn like the entire circuit that goes around the piece that you're interested in.
Right.
Yeah.
Like the first surface mount soldering I ever did was a circuit board for GoodFet that was handed to me by Travis Goodspeed. He was like, here, have a circuit board, solder this up, and you can do the thing you want to do. And I was like, okay, I'll try it. And like, the first time you order a PCB, maybe it should be somebody else's design. Maybe you should be building something that somebody else designed, and then after you kind of get the hang of building it, then you can try making a little modification to it.
Yeah.
And it's the exact same thing as software. Like people start not necessarily completely from scratch, but they start with somebody else's project and make a modification to it. Yeah. And that's one of the great things about open source hardware too. Sure. Is that it's following in the footsteps of open source software and allowing people to approach that learning curve from standing on the shoulders of other people.
Yeah. So from Bunny's talk at the beginning, he was talking about, he was comparing like all of the languages in software to hardware as well, and kind of like at least extolling the benefits of when you do learn hardware, you kind of have it for a longer time, and that it's a longer learning curve, but it's a good one to have, right? And so I've been thinking about that, and I've been thinking about like, how long does it take to do, like, so you have a hackathon, right? Like a hardware hackathon is going to be at least, if you're going to make hardware from scratch, it's going to be a week, right? Like just the turn cycles and the ordering parts, blah, 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 right? And then I was lamenting, but with a JavaScript hackathon, you could take a library, it's a thing that's already built, like you guys were talking about, and then have a thing in a day or less. And that's actually the benefit of it. You see this thing. And so when me and Jeff were talking about it earlier, we were like, and Peter as well, who's here, I was like, the thing I should have done with that workshop is I should have taught it backwards, right? The first thing you should do while you're installing KiCad is solder the board that's done. Then the next thing you should do is take the board that's already got all the parts there and do the layout. And then the next thing you should do is make the footprint. And then the next thing you should do is back associate it to a schematic. You know what I mean? Like,
interesting.
And that's kind of like what you were saying, Jeff. Like both of you were saying, it's like the idea of like starting from something that actually works first. Because I think that's another thing in hardware is that the dopamine is it's so far off. It's on the horizon. You know what I mean? Right. And it's like and to be completely honest about my workshop, like people left. Like they just. It was a 3-hour thing, and it was just it was too long. There's too many steps. So I think from now on, I'm going to try that other direction. At least get some people.
It's an interesting idea, and another thing that it's not quite reverse engineering, but it's engineering in reverse.
Yeah,
and
I like that.
But there's a benefit to both. There's a benefit to reverse. There's a benefit to forward engineering. There's a benefit to engineering in reverse. But there's also a benefit to reverse engineering, and that's something that I focus on a lot in my training. Is like, I'm trying to teach people who have generally some reverse engineering skills in the software world, and I'm trying to teach them reverse engineering of wireless systems, and it is kind of a way that you can get some kind of quick dopamine. Is looking at something that exists and is fully formed, and you're just trying to figure it out, as opposed to trying to build something from scratch.
Right. Well, that's the benefit, like Jeff, I mean, like kit building, right? That's a huge piece of kit building as well. Like there's, have, at least it's just follow directions. At the end, you have this thing. That's what a lot of people are looking for.
Yep, and I think it's up to whoever's doing the educating, like leading this experience, to make sure that the support is there, because if you go too far off course, you have to have the support to be able to get back on again. And like with kits, the hardest kits are the ones where you don't know if it works until the very end.
Yeah, right, that's a good point.
So it's like having those like milestones.
Right.
Interesting.
Right. Yeah, I always talk about the Wikipedia holes. You show someone a schematic, right? And they go off and they try and find out what a diode is, and then 4 hours later they're waist deep in a Wikipedia hole, like reading about silicon PNN, type semiconductors, right? And it's like, oh, well, start again tomorrow, hopefully, So
right.
Yeah.
I think that's part of. Oh, go ahead.
Go ahead. No,
I was going to say, I think that's part of why Arduino was so incredible, is that it solved a lot of the basic problems that people were having building electronic circuits. It had this platform that was already done for you, so that you had power, you had a microcontroller, you had interfaces, you had all the things that were essential to actually make the circuit work, and you could focus on like just the last mile of like doing the thing, adding the sensor or the LED or whatever. And same with Raspberry Pi. It's like you've got the development environment, you're adding something onto it, and it solves, like, you don't have to learn from scratch how to implement the thing that you're trying to do.
Yep. Yeah.
Totally.
Yeah, most people are just trying to get a thing out in the world. Well, we should continue to go get some more things out in the world ourselves here at Tour Camp. Thanks for sitting down and talking with us. I appreciate, you guys keep showing up for the Amp Hour. I appreciate that. So,
thanks. It's been great to see you, Chris.
Yeah.
Yeah. Thanks for having us.
Hang out again soon, I'm sure.